Hey, this is Mr. Grahn, 8.2 multiplying and dividing rational expressions. In this video, we're going to be focused on simplifying rational expressions, and that's about it. We're going to start with kind of the basics. We're going to learn about what a rational expression is and then how to start simplifying them. All right, so what is a rational expression? It's a quotient of two polynomials. Basically a fraction with equations in it. So if you look at these three equations, they're pretty standard examples of what a rational expression is. You've got an equation on top. Sometimes that equation is just a number, but most commonly it's some sort of a small polynomial, a linear or a quadratic or something like that. All right, so we're going to be basically reducing big fractions that have equations in them, right? So let's review a little bit about how we reduce some smaller fractions, okay? Looking at this one, 15 over 20. I think a lot of us are going to look at this and say, yep, it's 3 over 4. But let's think about why it's equal to 3 over 4. If I rewrite this in its factored form, what are the factors of 15? 15 is equal to 3 times 5. That's its prime factorization. 20 is equal to 4 times 5. Anytime I have something that matches on the top and the bottom of a fraction, when it's a product like this, it's a multiplication, that part can cancel out. Let's think about why that is. This is 3/4 times 5 over 5. What is 5 over 5? 5 divided by 5 is 1, so it's 3/4 times 1, which is just equal to 3 over 4. Similar line of reasoning for this one. Now, a lot of us can look at that and think back to our exponent rules and just know that this one cancels 1 from the top, or subtracting the exponents or something like that. But again, if I rewrite this as its factored form, it is x times x for x squared over x. Every x over x is just equal to 1. So those x's, this x over x cancels out, and what's left is just 1x, or x to the first. All right, so this is really the goal for this video is to be able to understand how to break down something that looks like this. We're going to simplify it. We're not going to worry with this one about the x values for which it's undefined, but we just want to worry about breaking this one down and simplifying it. There's a few different ways we can approach it. One way that I've seen a lot of students have success with is to break this into its individual parts, its matching parts. So focusing on the 10 over 6 and focusing on the x to the 8th over x to the 4th, right? Then it becomes basically just the same as the last slide where there was a 15 over 20 and an x squared over x. We can approach both of them separately to try to make this a little bit simpler. All right, 10 over 6. Both of them are divisible by 2, so we could reduce it that way. Or we could think of 10 as not 10 times 1, but 5 times 2. And we can think of 6 as 3 times 2. Then the 2's cancel out, and I'm just left with the 5 over 3 for that part. X to the 8th over x to the 4th. Now, I'm not going to do this for all of them, but if it's helpful, feel free to write them out the long way. X, 2, 3, 4, 5, 6, 7, 8 x's for x to the 8th, and 1, 2, 3, 4 x's for x to the 4th. And then every time you have 1 on top, it cancels 1 from the bottom, like that. What's left over that didn't get canceled out, that didn't get crossed out? On the top, a 5 and the product of 4 x's, so that is 5x to the 4th. And then 3 and everything else canceled out, so it's just 5x to the 4th over 3. All right, if you feel like you've got it, go ahead and pause the video and give these ones a shot. And then I'll go through them so you can check your work. All right, this one, the 3 over 2 doesn't reduce the x to the 7th over the x to the 4th. 4 of these cancel 4 from the top. So if those 4 cancel 4 from the top, there's going to be x cubed, x to the 3rd left over. Our next one 16 over 8, that reduces to 2 over 1. And then x to the 11th over x squared, 2 cancel 2, so there's going to be 9 left over. And if everything cancels in the denominator, that means that the denominator is 1. And we don't really have to write that, right? We would normally just write this as 2x to the 9th. If you wrote it like this, that's correct. It's not wrong. It's just you wouldn't normally write it like that. All right, this guy, the 3 doesn't have anything to cancel with on top, right? If there's no number there, that number's 1, and 1 over 3 doesn't reduce. Then this x, remember if there's no exponent, that is x to the first. 1 cancels 1, and it is x to the 4th. And then 1y down here cancels 1 from the top, so there's 3 left over. X to the 4th y cubed over 3. And then our last one, again, the 4 doesn't have anything to cancel with. X squared over x, the x cancels one of these, which will leave just x on top, and then y's totally cancel out, so there's no y's left over in the answer. It is just x over 4.